Hi there, welcome to my final presentation for EDLL604 Classroom Impact Project and Report and Presentation. My name is McDonald and I am a TFA Associate placed at Headland Senior High School in West Australia's Pilbara region. Please note that due to the involvement of human test subjects, participant consent was obtained prior to beginning any data collection and students were given the option to opt out of the following study. Ethical consent was sought from Headland Senior High School's Associate Principal Stephanie McDonald and was obtained prior to beginning the following project. The Australian Catholic University's Research Ethics Committee has also approved the following research under the taught ethics rules for completion within the EDLL604 unit. The following classroom impact project was conducted on a Year 9 class attending Headland Senior High School, a remote, independent public school located in South Headland, Western Australia. Headland Senior High School has a student population of 916, of roughly 1/3 who are Aboriginal and or Torres Strait Islander. According to ACARA, the school's index of socio-educational advantage is 918, with an unfortunate 41% of students sitting in the bottom SEA quartile. For this project, I decided to focus on my Year 9 Science Extension class, which at the beginning of the study consisted of 28 students, and upon completion of this study consisted of 30 students in total, owing to the transient nature of Headland as a mining town. The class itself is culturally diverse, with approximately 22% of the cohort who are Aboriginal and or Torres Strait Islander. There are also students from Portugal, the Philippines, New Zealand, and a number of other countries. Despite being an extension class, this class actually consists of a wide range of student abilities in terms of both literacy and numeracy, as well as science understanding. In semester 1 of this year, there were 8 students who did not pass science. The following table provides a snapshot of the initial data collected for this project. In terms of NAPLAN, the vast majority of students sat at the national minimums for reading, writing, and numeracy at the beginning of the project, and as mentioned previously, the majority of students passed science in semester 1. Due to the transient nature of Headland as a mining town, there were several changes to the class population during the project. The following table shows the enrolments and unenrolments that occurred during semester 2, and as students actually completed NAPLAN during this project, new NAPLAN data became available and is shown in the following table. As of now, 14 of the 30 students in this class are projected to not pass science in semester 2. As part of being in an extension class, students at Headland Senior High School must complete project-based learning as part of their overall science assessment. Project-based learning, or PBL, is a student-centered form of instruction born out of general observations of boredom and disengagement amongst secondary students and a deep lack of conceptual understanding of scientific material in students entering tertiary education. Heavily grounded in Bandura's and Vygotsky's social learning theories, PBL is based on the following 3 constructivist principles: that learning is context-specific, that learners must be actively engaged with the learning process, and that they must do so by interacting with others in order to achieve their goals. PBL was implemented at Headland Senior High School only a few years ago, and so far student reception has been relatively poor. Here you can see a number of issues students have voiced with PBL, including that it reduces their final semester grades and that they typically are unexcited about working with peers not within their immediate friendship groups. Of particular note here is the lack of experience students have with formal scientific report writing and the fact that they are often required to submit some sort of formal report as the final product of their PBL project. No instruction on how to write such a document is given, and while some students do have experience with writing aims, hypotheses, and other scientific writing structures, much of this writing is not done in a formal report structure. As a result, student beliefs about their abilities to be successful, also known as self-efficacy, tended to be low in the context of report writing. Additionally, as seen in Table 1, there are a number of students who neglected to submit their final report for PBL in semester 1 or who did not pass this component of their science assessment, both of which lead us to the identified learning issue for this project. So in addition to the observation that many students appeared to struggle with formal scientific report writing, it was also noted that students appeared to have low motivation for PBL and science in general, as well as poor self-efficacy in relation to their science knowledge and skills. These observations are supported by the data shown in Table 1, where students on average report low agreement with being good at science, as well as scientific writing. Students also on average appear to be neutral about whether they can be successful. Upon observing these issues, I decided to conduct a self-efficacy survey to determine student self-efficacy in 3 domains: emotional, academic, and social. As can be seen in Figure 1, students had relatively low emotional self-efficacy and ranked the highest in their social self-efficacy. Based on the learning issue identified, I decided to use the following 3 pedagogical foci to tackle issues of low self-efficacy and motivation in science. So explicit instruction, which typically follows an I do, we do, you do structure, is heavily reliant upon modelling skills to students, something which I believed would assist them in building their scientific report writing. Because effective explicit modelling should include the opportunities for independent practice and the provision of feedback, it was also selected for its potential in enhancing mastery experiences for students, something which has been linked to building self-efficacy. Student conferencing was selected to improve motivation by supporting student autonomy, providing talk opportunities, hints, and encouraging conversations. This strategy also allows the teacher to provide one-on-one feedback. Self-efficacy and self-regulation of motivation are highly linked, with the former playing a role in the development of the latter. Goal setting was selected due to its ability to potentially boost and sustain individual motivation as well as self-beliefs. Bringing together the identified learning issue with the previously mentioned pedagogical model, the following research question was comprised. In order to answer this question, an action plan was constructed in the context of interpretivist and pragmatic paradigms due to the proposed mixed methods approach of the study. The following slides demonstrate an example of the proposed timeline for data collection, as well as other types of data to be collected. As well as the types of data to be collected. So as can be seen here, the main types of data to be collected included conference notes as well as student responses to a modified academic self-efficacy survey, which is shown on a following slide. This table also shows proposed explicit instructional activities relating to improving scientific report writing, conferencing timelines, as well as goal setting and revision opportunities for students. I will now discuss the key findings of my project. To broadly start with, I looked at whether there was an improvement in students' academic self-efficacy from the beginning of the project compared to the end of the project, 15 teaching weeks later. Average academic self-efficacy at the beginning was ranked at 3 out of 5 overall, whilst upon completion of the project was ranked at 3.2 out of 5. Whilst there is a slight numerical difference here, this difference was determined to be not statistically significant, as shown with a p-value greater than 0.05. So using a t-test to analyze this data, there was no statistical significant difference between students' average self-efficacy before the project and after the project. Looking a bit deeper into the specific questions on the academic self-efficacy survey itself, the highest gains between the start and end of the project were seen in students' ability to pay attention during class, followed by their perceived ability to get teachers to assist them and their ability to pass all school projects or subjects. Negative gains were seen in students' ability to study a chapter for a test, which in hindsight I could have altered to study your class notes for a test, as students do not typically use textbooks outside of school. To determine whether there were any statistically significant differences in students' academic self-efficacy measured at different points during the project, a one-way ANOVA analysis was conducted. Here, I wanted to see whether students' academic self-efficacy improved from the beginning of the project compared to 3-week, 5-week, 10-week, and 14-week intervals into the project. So from the one-way ANOVA analysis conducted, it was shown overall that there was no difference no statistical difference between the average overall academic self-efficacy rankings initially versus the first measurement in Term 3, Week 3. Similarly, this was observed for Term 3, Week 5. Initial academic self-efficacy rankings at the start of the project were deemed to be statistically significant to third measurements taken in Term 3, Week 10. However, upon looking more closely at this result, it was shown that there were minimal data points, so only 6 students with initial results versus Term 3, Week 10 results due to absences across the project and the likely fact that this survey was conducted in Week 10 of the term. And the only significant difference between the initial and Term 3, Week 10 results was seen in a singular student. Again, with the initial versus Term 4, Week 5, there was no statistical difference between the overall average academic self-efficacy of students. As part of the final measurement taken in Week 5 of Term 4, I decided to compare students' academic self-efficacy rankings pre and post the students sitting their chemistry assessment. So t-test analyses showed that there were no statistical differences between the initial academic self-reported rankings versus those pre-test, initial versus post-test, and pre-test versus post-test. So none of these were deemed to be statistically significant. So no gains or no statistically significant gains in academic self-efficacy. Of note, there was an increase in students' ranking of how well they studied for a chapter after a test, and there were also decreasing average ranks in relation to passing their subjects as well as satisfying their parents with schoolwork, something I believe that is likely due to the fact that students completed this survey post receiving their test scores. In relation to students' goal setting, I decided to see whether particular self-reported strategies for reaching their goals had any impact on students' academic self-efficacy in relation to paying attention, passing their subjects, and passing tests in general. As can be seen in the following table, the only difference noted was that students who set goal-related strategies to improve their mindset reported higher rankings in relation to passing their school subjects. For the most part, however, self-reported goal reaching or specific strategies did not appear to be correlated with attention or passing abilities of students. So what does this data all mean? Based on the data presented, there appears to be no strong evidence to suggest that students' academic self-efficacy was able to be improved through the use of the nominated pedagogical foci. This, however, could be due to a number of reasons, including the fact that these may not have been the correct strategies to focus on in the first place, and that the strategies may not have been implemented correctly or as effectively as they could have been, or that they were simply not used enough within the time frame of the project. In fact, in an end-of-project survey conducted amongst students, it appeared that students were neutral about whether the nominated foci assisted their learning or not. Explicit instruction did rank highest as being helpful, with goal setting being the lowest. Of note here is the fact that these questions were not posed in the context of scientific writing specifically, and this was due to the fact that the final semester 2 projects themselves, as well as grades, were unavailable at the time of compiling and analysing this data. In general, however, we can see that these strategies in the context of everyday learning were used enough for students to not disagree that they were useful or not used, and certainly we are building scientific writing in general in our students in most lessons, but not necessarily report writing. Realistically, it is therefore hard to determine whether the strategies improved scientific writing specifically, but it is noted that they did not necessarily appear to have a large impact on students' academic self-efficacy overall. It is worth noting here that there are a number of factors which can impact students' academic self-efficacy throughout high school, and it has been found that self-efficacy beliefs tend to decline as students advance through school in general. This may be attributed to greater competition amongst peers, less teacher attention to individual student progress, and various stresses associated with student transitions. Participation has been shown to be heavily influenced by how much a school environment contributes to student perceptions of autonomy and relatedness, both of which can also influence self-efficacy and academic achievement. Greater focus on these areas and strategies to improve student perceptions of autonomy and relatedness may have helped me specifically to help build academic efficacy in this project, and would be certainly something I would look to talk about or implement in the future. In a study by Bartemore-Orflick et al., self-efficacy was shown to be strongly correlated with individual value, self-regulation and metacognition, locus of control, intrinsic motivation, and learning strategy use, suggesting that these may function as vehicles through which educators and or researchers may seek to either improve self-efficacy and or further understand it. In the same study, several strategies were suggested to raise self-efficacy and included the following. Some of these were incorporated into the current project. However, it appears there may be several other strategies teachers could use to look to raise self-efficacy in their students. Of particular interest to me would be the inclusion of identifying misconceptions, specifically in relation to scientific writing, as well as the inclusion of self-regulated learning instruction. In one study on how embedding self-regulated learning prompts into instructional videos for a flipped classroom, it was shown that by doing so, students' learning outcomes were enhanced. Another study in relation to explicitly teaching self-regulated strategies also showed gains in student performance. Student self-efficacy and self-regulation are positively intercorrelated and indeed predict student achievement, and this would be worth considering in any future endeavours or looking at employing within my regular classroom practice. So where does this leave me? Well, I plan to continue the use of explicit instruction in my classroom, not only because it was the most highly ranked strategy for assisting student learning, but also because of the wealth of research suggesting that it is a highly effective teaching strategy in general. I believe with more time, practice, and opportunities for students to demonstrate their scientific report writing skills, this strategy would help to lead to improved student academic self-efficacy. Despite goal setting being the least employed strategy as reported by students, I wish to look more into how I could use it more effectively in my classroom. I see daily in my classroom the effects of low student motivation on their willingness to complete work and seek to improve and challenge themselves, and therefore I wish to target future professional learning towards how I can better support my students' learning and self-efficacy and improve their self-efficacy through the use of goal setting as a tool. In conclusion, this project showed that the use of 3 pedagogical foci improves students' overall academic self-efficacy marginally. However, this difference was not deemed to be statistically significant. Due to time constraints and alterations to the United Extension program, PBL results were not available for comparison. However, there are a number of future implications as previously discussed for teaching and learning moving forward. I would like to say a massive thank you to my students for participating in this project, as well as to Mike Wetter for his consistent and tireless dedication to supporting adult learning at university. Thank you.